All right, so we wrapped up the last video saying that the derivative of sine inverse, of x was equal to 1 over the square root of 1 minus x squared. So that's kind of where we wrap things on up. And it's crucial to know this, guys. I'm not kind of trying to waste your time here, but it's crucial to know kind of where we get this from in order to make sense of the other trig function inverses, because we're not going to kind of show the proof per se for each of them. But this leads us into a formula that we can use for a chain rule circumstance and that we're dealing with. So let's say now, as a whole, I want to find the derivative of sine inverse for any function inside u, okay? I can use what we just found, the square root of 1 minus u squared, and multiply that by du dx, as long as u, in this case, is less than 1. Well, why is that? Because if the absolute value is less than 1, I'm never going to get a 0 here in the denominator, right? So we got to kind of keep that in mind as well. And so we're going to use this formula here to really focus on finding the derivatives of inverse trig functions for all circumstances and not just what the specific basic inverse derivative actually is. So let's dive into a first real kind of example for this lesson. So let's say I want to find the derivative dx of sine inverse of x squared now. Well, we know that derivative of sine inverse is going to be 1 over the square root of 1 minus x squared. We just talked about in the formula above that whatever this u function is, well, think about what our u function is right now. Our u function is x squared. Well, in this case, look what's happening. My u is getting squared. And so I need to take what u is and just kind of, for lack of a better terms, plug it into the formula itself. So let's take a look. This is going to lead us into 1 over the square root of 1 minus x squared quantity squared, because there's my u and x squared, and I'm squaring it based on our formula. And then I need to multiply it by the derivative of u itself. Well, the derivative of u, because remember u was x squared, is 2x. So I multiplied it by du dx. So it's the derivative of x squared. And kind of letting this all come to fruition, this just simplifies down to 2x over the square root of 1 minus x to the fourth. And that's as simplified as it's going to get and as easy as it's going to get as well. And we can use that same concept for any type of derivative with sine, as long as we understand the formula is 1 over the square root of 1 minus whatever the u is, quantity squared. Now, kind of take into perspective that the u is not always going to be x squared. The u could be a chain rule, it could be a product rule, it could be a quotient rule. But as long as you understand that it's just the quantity of u squared inside that square root and multiply it by the derivative of u, you should be good to go. Now, thinking about this with this last concept in mind here, give this one a shot on your own. Find the derivative, in this case, of y equals, I guess it's with respect to t in this example, y equals sine inverse of the square root of 2t. Give that one a shot on your own, guys, right here. Find the derivative of this function. And hopefully you guys will see that the answer comes out to square root of 2 over the square root of 1 minus 2t squared. So check your answers, guys. Hopefully you guys got it correct, and we'll look into it first thing.